We're going to take a look at some other constructions. And just to be clear, this is not an exhaustive list of every construction that we could do. We're just going to look at some constructions that we can make based on some of the other constructions that we've already done. So there would be additional constructions that you could be asked to do based on these constructions as well. So let's start by thinking about a rhombus and how we would construct a rhombus. We know that a rhombus has four congruent sides, the opposite angles are congruent, and the opposite sides are parallel. And those are actually very useful properties to know about a rhombus, which will help us create other constructions from the construction of a rhombus. So let's actually construct a rhombus and see what's going on. The first thing we're going to do is create an angle that will represent one of the angles that's contained within the rhombus. Now it's possible that we'd be making a construction in which we've already been given an angle, and what we're asked to do is copy that angle. In this case, that's not what's happening. We haven't been given any information about any of the angles inside this rhombus. So we're just going to make a decision that this is one of the angles inside the rhombus. If we had been given an angle that was supposed to be contained within the rhombus, we would have to copy that angle at this point. So now that I've got an angle that's contained within the rhombus, I'm going to make a decision about how long each side of the rhombus is. If I'd been given some information about how long the sides would be, I would have to use the compass to measure that distance, but I wasn't given that information. So I'm going to make a decision. Here's how long each side of the rhombus will be. I'll make an arc to show where two more vertices of this rhombus are going to be. They're going to be through those intersections we just made. And now I need to find the last vertex of the rhombus. So somewhere out in the middle of that angle, I know that we're going to have a vertex of the rhombus. And I know that the distance between the vertex that's indicated at the intersection we just made and this mystery vertex is still the same distance that we've got our compass set to. So if we make an arc from each of these intersections that represent two more vertices, the intersection of these two arcs will be the last vertex for our rhombus. And now that we've got all of our vertices, we're just going to use our straight edge to connect up those vertices and make our rhombus. So let's bring the straight edge back in, and if we connect up these two intersections, we'll have a third side of our rhombus. So from here to here. And if we connect up the other two vertices, we'll have the fourth side of our rhombus. So we'll straighten out that ruler and connect up the last two vertices. And there we have it. We have a rhombus, a quadrilateral with four congruent sides. Now these properties of a rhombus, that it has four congruent sides, the opposite angles are congruent, and the opposite sides are parallel, allow us to make a lot of other constructions based on the construction of a rhombus. And one of those constructions is this one, to construct a bisector of an angle. So let's look at that construction, how to bisect an angle. So here's the angle. Bisecting it means dividing it into two equal angles. First we're going to make arcs through both rays of the angle from its vertex, and then arcs from each of those intersections. If we connect up the vertex of the angle with the intersection that's out in the middle of the angle, we've bisected the angle. There's a connection between the construction of an angle bisector and the construction of a rhombus. Here's what we did when we constructed a rhombus. And here's what happens when you construct an angle bisector. If you look at the arcs in the pictures, you'll see that the arcs are in exactly the same place. The only difference in the two pictures is that in the one where we construct a rhombus, we connect up those intersections to show that we have a quadrilateral with 4 congruent sides. And in the construction of the angle bisector, we only connect up the intersections, which would in essence be opposite vertices of the quadrilateral. Now remember, the properties of a rhombus are what allow us to make these constructions happen. Their opposite sides are parallel and all the sides are congruent. Now there's some other properties that a rhombus has. Well, not really properties, it's theorems about rhombuses or rhombi. That is that the diagonals are perpendicular and that the diagonals will bisect all of its angles. Now we're calling those theorems because they really need to be proven. And we'll be looking at geometric proofs to prove that the diagonals are perpendicular and to prove that the diagonals bisect its angles. But we're really using those theorems in order to make our constructions. If you look on page 772 and 773, you'll see a nice description of these theorems, these properties that will be helpful when we're not only making constructions, but when we're making proofs as well. So let's look at another construction that is actually based on something we've already done. This is constructing a perpendicular to a line which passes through a point not on the line. So what we'll be starting with in this construction is a line and a point that's not on the line. First, we'll stretch the compass out to some distance that's greater than the distance from the point to the line and make 2 arcs on the line. And then from each of those intersections, we'll make 2 more intersecting arcs on the opposite side of the line from the point. If you connect up that intersection with the point, you're going to have a perpendicular drawn through the point to the line. So take a look at this picture. This is basically what was done in the construction. And if you look at these intersections, what you'll see is that we've actually constructed another rhombus. So once again, the rhombus is playing a role in the construction of something that maybe doesn't seem like it's connected to a rhombus, but it really is. Okay, how about if we want to construct a perpendicular to a line that passes through a point that is on the line? Let's take a look at that construction. So remember, we're starting with a line and a point that's on the line. And we want a perpendicular through that point. So the first thing we'll do is from the point, make arcs that are the same distance from the point. Then stretch the compass out longer, and through each of those intersections, make an intersection above or below actually the point. In this case it's above. And now if we connect up that point with the intersection, we've got a perpendicular to the line through the point that's on the line. Now if you think about what we saw in that construction, you may have noticed that there was a rhombus also in that construction. It's just what we're choosing to connect up that makes the construction that we're interested in. In this case, the perpendicular to the line, which passes through a point on the line. Now let's look at parallel constructions. What if we want to construct a parallel to a line which passes through a given point? Obviously, that given point can't be on the line. Now this is a good opportunity to point out that in many cases there's more than one way to make these constructions. This particular construction relies on what we know about rhombuses to create this parallel line to another line that goes through a point. So there's our line and the point that we want our parallel to go through. We make an arc from that point that passes through the line twice. Then we make an arc from the intersection to the line. We make an arc from that new intersection at point E through the semicircle or partial circle that we drew. And then finally we can connect up that intersection at S to the point that we want to be contained on our parallel line. And now we have a line through R and S that's parallel to the line that we started with. So basically here's the important arcs that we saw in that construction. And if you'll notice, we can connect up those intersections in a completely different way to create a rhombus. We simply chose to connect up the point with the intersection that's not on the line to create our parallel line through the point. Remember, there's more than one way to do many of these constructions. This is a completely different approach to constructing a parallel to a line through a point not on the line. And what this construction relies on is copying an angle. It really doesn't matter which of the methods you would use to construct a parallel line through a point. What is important is whatever construction you do choose to use, you have to tell the story of your construction through the arcs that you create in your construction. So here's a bit of a challenge for you. I'm not going to show you how to do these constructions, but you actually have all of the necessary knowledge to do these constructions. See if you know how to construct a parallelogram, a kite, and a rectangle. What you need to think about before you try the constructions is what makes each of these shapes what they are. What makes a parallelogram a parallelogram? What are the important properties that you can use in your construction? What makes a rectangle a rectangle? What do you need to construct in order to make sure that you have properties in your figure that are the same properties that a rectangle has? So see if you can make those constructions. We'll practice more of them in class, and we'll see how all of these constructions that we've used really do work together to create other types of constructions.